Hello students, today we are going to start with chemical equation. Chemical equation is a representation of chemical reaction using symbols and formulae. Now in this chemical equation we have two parts. One is left hand side and one is right hand side. Reactants are always written to the left hand side and products are always written to the right hand side. So let's take an example. You have A and B. Now this A and B is connected with a plus sign and we call it as reactants. With the arrow which indicates that to obtain or to yield, and what we get is C and D. If you have one product, then you are going to just write the product. But if you have more than one, the products are also being connected with the plus sign. So this part we consider it as products. The word equation is used because atom is neither be created nor destroyed in chemical reaction. Okay? Now, let's see what do you mean by reactant. Reactants are the substance that is taking part in the chemical reaction. So we call it as reactants. And we'll see what do you mean by products. Products are the substance that are being formed due to chemical change in a chemical reaction. Okay? Now, here, based on this, we should know what do you mean by balanced chemical equation. When the number of atoms of each element present to the left hand side is equal to the number of atoms of each element present to the right hand side, we call it as balanced chemical equation. Now in this we have a term, that unbalanced chemical equation, which we call it as skeletal equation. Let's take one example. You have Mg plus HCl gives MgCl2 plus H2. Now if you try to compare the number of atoms to the left hand side and that to the right hand side, the equation is not balanced. Here you have 1 Mg, here also you have 1 Mg. Here you have 1 hydrogen, but here you have 2 hydrogen. Here you have 1 chlorine, here you have 2 chlorine. So the equation is not balanced. So this equation we call it as skeletal equation or unbalanced chemical equation. So second part, we are going to see balancing chemical equations by heat and trial method. So let's take the same example. You have Mg plus HCl gives MgCl2 plus H2. Remember, in this equation, you have to only change the value of coefficient. So whatever value you are going to put over here, only that value you are going to change. And you are not going to change any of the subscript of the compound or of the element. Okay? So now here, let's see. You have Mg1 over here. Here also it is 1. Hydrogen is 1. Here you have 2. So in order to make this 2, you are going to put a number 2. So when you are adding 2 over here, this 2 is applicable for hydrogen also. At the same time, this 2 is applicable for chlorine also. Now let's see again. Mg is 1, Mg is 1. Hydrogen is 2. Hydrogen over here is also 2. Chlorine is also 2 and this chlorine is also 2. So the equation is balanced. That is, left hand side is equals to right hand side. Okay? So the equation is balanced. Let's take one more example. You have MgOH twice plus HCl gives MgCl2 plus H2O. Now let's try and compare. Mg is 1, here also it is 1. Oxygen is 2. Oxygen, whatever is written outside the bracket, that 2 is applicable for both. That is for oxygen also, for hydrogen also. Oxygen is 2, so here oxygen is 1. So in order to make it 2, we are going to put 2 over here. So now the moment I put 2 over here, hydrogen is over here 2 and this is 1. But over here hydrogen is 2. Sorry, hydrogen is 4. Let's see chlorine over here. Chlorine is 1 over here and we have 2. So in order to make it, we'll put 2 over here. Now, the moment we put 2 over here, hydrogen is also balanced. 2 hydrogen plus 2 hydrogen equals to 4 hydrogen. So I'll just write Mg is 1, oxygen is 2, hydrogen is 4, this 2 and chlorine is 2. To the right hand side, Mg is 1, chlorine is 2, hydrogen is 2 2s are 4 and oxygen is 2. So the equation is Mg1, oxygen 2, hydrogen 4 and chlorine is 2. So the equation is balanced. Let's go for the third equation. You have Fe plus O2 gives Fe2O3. Now in this case, Fe is 1 and here you have 2. So you are going to put 2 over here. So now the moment you put 2, oxygen is 3 and over here oxygen is 2 and here oxygen is 3. So how you are going to balance this? You have to convert this into even number. If you multiply, here you have 3 and here you have 2. So this is 3, so you have to make this also 3. So I can write it in a fraction. Here already you have 2 and if I write it in a fraction as 3 by 2. So here I get the answer as 3 and here already you have 3. So I put 3 by 2. Now remember, in a chemical equation, you cannot write it in a fraction. You have to convert it into whole number. So in that case, what we have to do? The entire equation, we are going to multiply it by 2 because we want to get rid of this fraction. So if I multiply this entire equation by 2, Fe 2 into 2 will become 4 Fe plus 3 by 2 into 2. So it is 3 by 2 into 2. So 2 and 2 is getting cancelled. So you have 3 O2. Same way, 2 into Fe2O3 will be 2 Fe2O3. So let's check the number of atoms to the left hand side and that to the right hand side. Fe, you have 4. Here also Fe is 2 2s are 4. Oxygen, 3 2s are 6 and here oxygen 3 2s are 6. So the equation is balanced. So you can use a fraction, but remember you cannot keep it in a fraction. You have to convert it into whole numbers. Let's take one more example. Fourth one. You have FeS2 plus O2 gives Fe2O3 plus SO2. So now here, first we will try balancing with iron. So iron here is 1 and here you have 2. So I'll put 2 over here. Okay. So now what is the sulfur? Sulfur becomes 4. So here I'll put 4. Now oxygen to the left hand side you have 2 and oxygen to the right hand side you have 3 plus 4 twos are 8, which is becoming 11. 8 plus 3 is 11. So in order to make it 11, what I will do? I will convert it into fraction. So I will put 11 by 2. So now we need to get rid of this fraction. So what we are going to do? If you divide this by 2, the entire this fraction will get cancelled and will be converted into whole number. So I will multiply the entire equation by 2. So this will become 2 into 2. 2 twos are 4. FES2 plus here 11 by 2 into 2. 2 will get cancelled, so it will remain 11O2 gives 2 into Fe2O3 will be 2 Fe2O3 plus 4 into 2 is 8 SO2. So let's check if it is balanced. Fe is 4. To the right hand side, Fe is 4. Sulfur is 8. 4 twos are 8. Over here, sulfur is 8. Oxygen, 11 twos are 22. And here, oxygen is 3 twos are 6 plus 8 twos are 16, which is equals to 22. So the equation is balanced. Let's go for the next example. Now, here carbon is 3, here it is 1. So in order to make it 3, we will put 3 over here. So carbon is 3, here also it is 3. Hydrogen, you have 8 and here it is 2. So how you will make it 8? 4 into 2. So 4 twos are 8. So hydrogen is 8, here also it is 8. Let's check for oxygen. To the left hand side you have 2 and to the right hand side 3 twos are 6 plus this 4. So it will be 10. So how I will make it 10? I will multiply it by 5. So here let's check again. Carbon is 3. To the right hand side, carbon is 3. Hydrogen is 8. To the right hand side, hydrogen is 4 twos are 8. Oxygen, 5 twos are 10. And here oxygen is 3 twos are 6 plus this 4 will be 10. So the equation is balanced. Let's go for the next equation. You have C2 and here you have 1 carbon. So I'll put 2 over here. Now let's go for the next H6. So here we have only 2. So to make it 6, we will multiply it by 3. 3 twos are 6. Now let's go for oxygen. Oxygen is 2 over here and to the right hand side you have 2 twos are 4 plus 3, which is 7. How you will make it 7? I will write it in a fraction. So if I write it in a fraction, it will become 7. That is 7 by 2 into 2. So it will be 7. So now as I have said, if you want to get rid of this fraction, we have to multiply the entire equation by 2. So we'll multiply it by 2. It will become 2C2H6 plus 7 by 2 into 2 will be 7O2 gives 2 twos are 4 CO2 plus 3 twos are 6 H2O. Let's check if it is balanced. Carbon is 4. To the right hand side it is 4. Hydrogen 6 twos are 12. Your hydrogen 6 twos are 12. Oxygen 7 twos are 14 and your oxygen 4 twos are 8 plus the 6, which will be 6 plus 8 is 14. So the Now, we will take the other example. You will be given the formula. Sorry, you will be given the name of the compound and you have to write the formula and then you have to balance the equation. So I will give you all some examples. Write the formula and then balance the following equations. So let me give the first example. Sodium hydroxide plus dilute sulfuric acid gives sodium sulfate plus water. Let's take first example. You have sodium hydroxide combining with dilute sulfuric acid. What you obtain is sodium sulfate and water. Now what is the formula of sodium hydroxide? It is NaOH plus dilute sulfuric acid. It is H2SO4, which gives sodium sulfate. Now with the crisscross method, you can able to find the compound. You can be able to find the formula. Sodium is Na, sulfate is SO4, the valency of sodium is 1 and that of sulfate is 2. So with the it will be Na2SO4 1, wherein we don't write 1, it is understood. So it is Na2SO4 plus water, that is H2O. So now we'll start balancing. Na over here is 1 and here you have 2. So I'll put 2 over here. So now sodium is balanced. Let's check for oxygen. Oxygen is 2 plus 4, which is 6. And here you have 4 and here you have 1. So what I will do? I'll put 2 over here. Let's check. You have 4 and 2. Oxygen is 6. So this side also it is balanced. That side also it is balanced. Hydrogen, you have 2 and this is also 2. So 2 plus 2 becomes 4 and here also you have 2 into 2 which is 4. So now sulfur is 1 and here also it is 1. So the entire equation is balanced. Let's take second example. Copper to sulfide plus oxygen gives oxide plus sulfur dioxide. Now copper to oxide. Copper is having valency 2. Sulfide is also 2. So 2 and 2 will get cancelled. So you are remaining with CuS. Combining with oxygen. So oxygen is a gas. Diatomic molecule. We will write it as O2. What you will get? Copper to oxide. Again copper valency is 2 and oxygen is also 2, that is oxide. So it will get cancelled and you are going to remain with CuO plus sulfur dioxide. Sulfur and oxygen 2. So SO2. So now we will start balancing. Copper here is 1, here also it is 1. Sulfur is also 1, here also sulfur is 1. Oxygen here is 2, but here you have 2 plus 1, 3. So how you are going to make it 3? Again, let's take it in a fraction. So 3 by 2. So what you are going to do? In order to get rid of this fraction, you will multiply the entire equation by 2. So once you multiply, it will become 2CuS plus 2 and 2 will get cancelled. 3O2 gives. Again 2 into CuO will be 2CuO plus 2SO. So we'll check if it is balanced. Copper here is 2. Here also copper is 2. Sulfur is 2. Sulfur here is also 2. Let's check for oxygen. Oxygen is 3 2s are 6. Oxygen over here is 2 plus 2 2s are 4, which is equal to 6. So the equation is balanced. Let's take one more example. Copper 2 oxide plus ammonia gives copper plus nitrogen plus water. So now copper 2 oxide, as we have written, copper is valency 2, oxygen is also 2. So 2 and 2 will get cancelled. So 2 and 2 will get cancelled. So you are remaining with CuO. Okay. Now ammonia, we know the formula. It is NH3. Correct. So NH3, you will get copper. Now copper here is aluminum, so it will be Cu plus nitrogen. We have studied nitrogen is a diatomic molecule, so it will be N2 plus water, that is H2. So let's check balancing. Copper here is 1, here also it is 1. Oxygen is 1, here also it is 1. Nitrogen is 1, nitrogen over here is 2, so I put 2. So hydrogen becomes 3 2s are 6, and over here hydrogen is 2. So to make it 6, I multiply it by 3. So 3 2s are 6. But the change is oxygen is become 3 and here oxygen is 1. Okay. So what I will do? I can put a number 3 over here so that the oxygen is balanced. So now what about copper? Copper is also changed to 3. So I will put 3 over here. Let's check this equation again. Copper is 3. Here copper is 3. Oxygen is, this 3 is multiplied to this. Oxygen becomes 3. Oxygen to the right hand side is also 3. Nitrogen, you have 2. Nitrogen here is 2. Hydrogen is 3 2s are 6. 3 2s are 6. And over here hydrogen will be 3 2s are 6. So the equation is balanced. Let's go for one more example. You have ammonia plus oxygen gives nitrogen plus water. One more. Ammonia plus oxygen gives nitric oxide plus water. So you all just try to solve this example. Okay. So you all tell me, for ammonia, what formula you are going to use? NH3, correct. Ammonia is NH3. Oxygen. What are you going to write for oxygen? Is it O or O2? Yes. Oxygen is diatomic molecule. So it will be O2. Nitrogen. Again it is diatomic. It will be N2 plus water. That is H2O. Now just start balancing. Nitrogen here is 1. Here it is 2. So what I will do? I will multiply it by 2. So nitrogen is 2, but this 2 is multiplied to hydrogen also. Hydrogen will become 3 2s are 6, and over here hydrogen is 2. So what I will do? I will multiply it by 3, so that will become 6. But what about oxygen? Oxygen here is 2 and here it is 3. So you can only change over here. So to make it as 3, what I will do? I will write it in a fraction. Correct. So it is 3 by 2. So now we will not keep it in a fraction. We have to convert it into whole number. So I will multiply the entire equation by 2. So what will be the change? 2 2s are 4. Correct. 4 NH3 plus 2 and 2 will get cancelled. So it will be 3 O2 gives 2 into N2 will be 2 N2 plus 3 2s are 6 H2O. So let's check. Nitrogen over here, I'll just write it over here. Nitrogen is 4. Nitrogen over here is 4. Hydrogen, 4 3s are 12. Sorry, 12. And your hydrogen is 6 2s are 12. Oxygen, 3 2s are 6, and oxygen 6 into 1 will be 6. So the equation is balanced. Let's try the last example. I hope you all must have solved this. So ammonia is NH3. Oxygen is O2. Correct. Nitric oxide. So nitric oxide formula is NO plus water. That is H2O. So we'll try balancing this. Nitrogen is 1. Here also it is 1. So nitrogen is balanced. Hydrogen is 3. But over here is 2. So in order to make it same, what I will do? I will multiply here by 2. And here I will multiply it by 3. So this will become 6. And here also 3 2s are 6. But what about oxygen? Sorry, what about nitrogen? Nitrogen is changed. Nitrogen has become 2. So what I will do? I will put 2 over here. So nitrogen is balanced. 2 nitrogen, 2 nitrogen. Then 6 hydrogen, 6 hydrogen. But what about oxygen? Oxygen is over here 2 and over here 2 and 3, which is equals to 5. I have to only change the coefficient value. So it is 5. So in order to make it as 5, I will write it in a fraction. So how you can make it as 5? So here you have already 2 and you have to make it as 5. So it will be 5 upon 2. So are you going to keep it in a fraction? No. We will multiply the entire equation by 2. Okay? So that 2 into 2 will be 4 NH3 plus 2 and 2 will get cancelled. We are going to remain with 5 O2 gives 2 into 2 will be 4 NO plus 3 2s are 6 H2O. Let's check. Nitrogen over here is 4. Over here is also 4. Hydrogen is 4 3s are 12. And your hydrogen is 6 2s are 12. Oxygen, 5 2s are 10. And your oxygen, you have 4 plus you have 6, which is equals to 10. So the equation is balanced. Now we will see the information conveyed by balanced chemical equation. Balanced chemical equation tells us about the number of substances that are reacting and the number of substance that is being obtained after the reaction. It also tells us about the number of atoms and molecules involved in a chemical reaction. The balanced chemical equation also tells us about the symbols and the formulas involved in a chemical reaction. It also tells us about the mass of the substance that are reacting and the mass of the substance that is being obtained. Now we will see the limitations of balanced chemical equation. Now balanced chemical equation does not tell us about the physical state of a substance, whether the substance is in solid state, liquid state or gaseous state. Or else you can also write the watery solution, which we call it as aqueous solution. So this problem was overcome by using the symbols. So whenever the equation was written, to the compound, the symbol S, L, G or aqueous was written. Second limitation is, it does not tell us about whether the reaction is come to completion or not. Third limitation is, the balanced chemical equation does not tell us about the speed of the reaction. Fourth, it does not tell us about the conditions that are required to bring about chemical reaction. For example, you have temperature, pressure, catalyst, then heat energy, light energy and many more. Again, this problem was also overcome by writing these conditions in a form on the top of arrow, wherein the equation was carried out. Again, the last limitation is, it does not tell us about the change in the color. It does not tell us about the precipitation. It does not tell us about the evolution of heat. So today we have studied chemical equation, balancing of chemical equations and the information that has been conveyed and the limitations of by the balanced chemical equation.